In this video, I'm going to show you how to factor four-term cubic expressions using the method of grouping. So we want to factor this expression here, x cubed minus 3x squared plus 2x minus 6. And we're going to use the method of grouping, which corresponds to 3 steps here. The first step is to group the two highest order terms and the two lowest order terms. So the two highest order terms are the x cubed and the x squared here. So let's write these in parentheses. So parenthesis x cubed minus 3x squared, and then group the other two terms in parentheses. These are the lowest order terms, just x to the first power and x to the 0 power, or just the constant. So 2x minus 6 in parentheses here. Okay, so we've visually separated these, and now we're going to think about each of these groups independently for step 2. Step 2 is to factor each group to reveal a common binomial factor. So we're going to let's look at this group first, x cubed minus 3x squared. Do we see any common factors between these two terms, x cubed and minus 3x squared? Well, they both have x in them. Can we do any better? Actually, they both have x squared in them. And that seems to be about it. So let's factor out an x squared. So this is x squared. And then, so once we factor out that x squared out of x cubed, what's left over? Well, x squared times what makes x cubed? Just x squared times x. And then x squared times what makes negative 3x squared? Well, just negative 3. Okay, cool. So if we were to multiply this out, we should get back to where we started, x cubed minus 3x squared. And indeed, that's what we'll get. But we're doing this so that we can reveal a common binomial factor. So we've got a binomial factor, x minus 3, and we want to factor out something out of this group now to also reveal an x minus 3. So let's do that. So plus, what can we factor out of this group here? Is there anything in common? Well, we can't factor out an x this time because that term doesn't have any x. But these terms both have coefficients. Do the coefficients have any common factors? Oh, they're both even. So we can factor out a 2 out of both of them. So let's do that. Let's factor out a 2. And then what goes inside the parentheses? Well, 2 times what makes 2x? Just x. And then minus 2 times what makes 6? 3. Okay, cool. So if we expand this out, 2x minus 6, that matches what we had before. But now we see that we have a common binomial factor in both groups. There's x minus 3 here and x minus 3 here. Great, so that leads us to the final step here. We want to factor the expression completely. We are just going to factor out this common binomial factor out of both of these terms here. So let's do that. So we factor out the common binomial factor. So let's put in x minus 3 on the outside, and then x minus 3 times x squared makes the first term. And then x minus 3 times plus 2 makes the second term here. And can we factor that quadratic anymore? No, it doesn't look like it. So we're done. So that's our final result. That is the factored form of this cubic expression. Now, this is a really slick trick for factoring, and it'd be really nice if it worked on all kinds of cubic expressions. Unfortunately, it only works for some four-term cubics. It doesn't work for all of them, but it's still a useful tool to have in our tool belt in case we encounter cubics which can be factored this way, because it's just a really easy way to do so. Here is a similar problem. We want to factor this four-term cubic expression, 2x cubed minus 8x squared minus 3x plus 12. And we're just going to do the same steps as last time. This one's going to be a bit trickier, as we'll see. But to start off, it's the same idea. Group the two highest order terms and the two lowest order terms. Highest order terms are the x cubed and the x squared, so we'll group up those. So we've got 2x cubed minus 8x squared. And then we'll also group up the lowest order terms, the x term and the constant. So just plus negative 3x plus 12. And now we're ready to proceed to step 2, factor each group to reveal a common binomial factor. So looking at this left group, First, 2x cubed minus 8x squared. Do we see anything that is common to each of these terms? Any common factors here? So looking at they both have x like last time. Actually, they both have x squared like last time. So we can factor out an x squared. Is there anything else that we can factor? Now they have coefficients, and both coefficients are even, which means they're both divisible by 2, so we can factor out a 2 also. So 2x squared times what gives us this? Well, 2x squared times what makes 2x cubed? The only difference is an x there. So that'll be our first term. And then minus 2x squared times what gives us 8x squared? Well, we don't need any additional x, but we do need to multiply the 2 by 4 to get to 8. So we've got x minus 4. There we go. And if we multiply that out, 2x squared times x, that's 2x cubed. 2x squared times 4, that's 8x squared. Yeah, that checks out. Okay, now let's do the next one. So plus any common factors here. So we can't factor out an x because constant doesn't have an x. So look at the coefficients, -3 and 12. Maybe just think 3 and 12. Do those have any common factors? Well, yeah, they're both divisible by 3. 3 is a factor of 12, so we can factor out a 3 from both. So 3 times what makes -3x? Well, just 3 times -x. And then plus 3 times what makes 12? Just 3 times 4. Okay, great. So we've got that factored. Okay, and we want to reveal a common binomial factor. And, ooh, it looks like we're pretty close, but there's something that's wrong here. X minus 4 and -x plus 4. We have x and 4 in both of them, but the minus is in the wrong place in the second factor. It's on the x. We really want it between the x and the 4. So how can we fix this? Well, you notice that if we apply a negative sign to both of these terms, then it'll switch. Like the negative of -x would just make x, and the negative of +4 would just make -4. So why don't we also factor out a negative here? So we'll do 2x squared times x minus 4, and then instead of plus 3x, we'll also factor out a negative, so minus 3. And then what goes in the parentheses? Well, when you factor out a negative, now this x becomes positive, because negative times x makes our negative x here, and this 4 becomes negative. It flips the sign, because negative times -4 makes +4. Okay, great. So now everything is all right. We've got our x minus 4. That's our common binomial factor in both terms, and we're ready to factor the expression completely. We can just factor out that x minus 4 term from both of these terms. So let's write that. We'll put in parentheses and then another parentheses. Second parentheses will have our x minus 4. And then x minus 4 times what makes these two terms? So x minus 4 times 2x squared makes the first term. And then x minus 4 times minus 3 makes the second term. So 2x squared minus 3 times x minus 4. There we go. Can we factor the quadratic anymore? No, it doesn't look like it. So we're done. 2x squared minus 3 times x minus 4. That's the factored form of this cubic expression. Here's a final example. Let's factor this cubic, -2x cubed minus x squared plus 18x plus 9. So first up, we want to group the two highest order terms and the two lowest order terms. But actually, before we go into this first step, we're used to working with a positive leading coefficient, and this negative will be kind of annoying to deal with on the leading x cubed term. So why don't we let's start by factoring out a negative. So let's factor out a negative from all the terms here. Negative, so all the terms flip sign, negative of 2x cubed, then plus x squared, then minus 18x, then minus 9. And now we have a nice positive leading coefficient, and we can just carry the negative through and just apply it at the very end. So now we're just worrying about this expression inside of the brackets. And we can proceed with that with the first step, group the two highest order terms and the two lowest order terms. We'll just group these terms here and these terms here. So let's write that. Group the x cubed and the x squared. So 2x cubed plus x squared, and then plus negative 18x on minus 9. Okay, so now we want to factor each group to reveal a common binomial factor. So let's write this down. So negative of, in brackets, this whole thing, and let's look at this first group here. What common factor do we have here? So we've got x squared in both of these, and that looks like about it. So factor out an x squared. Then what's left over the first term? Well, there's a 2 left over, also an x left over. And then how about the second term? Well, that's itself, so just plus 1. Okay, great. And now let's factor this next group here. So we see there's a negative in both of these terms. So why don't we factor out a negative? And what else is common? Only one of the terms has an x, but they both have multiples of 9 as coefficients, 18 and 9. So let's factor out a 9. So negative and 9. So what's left in this first term here, negative 18x? Well, that just reduces down to 2x. And how about the second term, minus 9? Well, that's exactly the same as here, so just plus 1. Okay, great. So now we've factored the groups, and we've got a common binomial factor, 2x plus 1, 2x plus 1, and now we are ready to factor the expression completely. So let's go ahead and do that. We've got negative, and then let's group up, let's factor out a 2x plus 1, 2x plus 1, and then 2x plus 1 times x squared makes this term, then 2x plus 1 times minus 9 makes this term. And then, great, so we just have a leading negative inside of there. But hold on though, let's look at the quadratic. Can we factor this anymore? Look, this is a perfect difference of squares. X squared minus 9 is just 3 squared. So yeah, we can factor the quadratic a little bit more. So let's go ahead and do that. So minus x squared minus 9 just factors to x plus 3, and then x minus 3. And then that is times 2x plus 1. Okay, so now the remaining thing is, we could be done right now, but just to clean this up, let's distribute this minus sign into one of these factors, which would make it look the most clean. Why don't we choose a factor that already has a minus sign in it? That way the minus sign will cancel with the minus sign, and we'll just be left with a single minus sign on the x here instead of like 2, as we would in any other factor that we distributed it. So let's go ahead and do that. So x plus 3, and distribute that minus to this factor here, negative x plus 3, and then 2x plus 1, so our last factor. You know, to clean this up even more, we could just switch this around and say 3 minus x. Yeah, that would look nice. So x plus 3, and then 3 minus x, and then 2x plus 1. And there we go, factored form. We're all done. So now we see how to use the method of grouping to factor some 4-term cubic expressions, and in the future we'll also see how to use the method of grouping to solve some cubic equations.